Hello, welcome back. In this lecture, we are going to start discuss about collections. So this chapter about a collection is chapter 19. Uh, the major topics that we are going to go over in this chapter include Java Collections Framework, the definition, and the Java Collections Interface Hierarchy, implementations of the Java Collections interfaces, and the coding examples about list application, queue application, set application, map application, and algorithms in the framework. So the first section in this chapter is about the Java Collections framework. So what is the framework? So basically, it is a system for representing and manipulation collections. Okay, so here collections is um, a group of data structures. Okay, and there are three components in Java collections framework. So it has interface and classes. So those classes will implement the interface, and there are also algorithms. Okay. So the interface, the purpose is to define a set of operations and common to some specific category of data structures. Okay, so we will see. So it's some category of data structures. So for example, the list interface, if you recall in previous chapter, we also saw that. And the second component is classes. So classes, like in this diagram shows, it implement interface. And they represent some implementations of the specific interfaces. Okay, for example, the linked list classes, and we already use a linked list in our previous chapters. And the third component is algorithms. Okay, so algorithm is not about some specific category of data structure. Okay, so what they are is they provide some general operations, general methods to perform some common operations. For example, if you do search or if you do sorting, is that so? And it can be applied to a certain group of data structures. Okay, so that's the third part. Okay, so that's the general idea about Java collections framework. Okay, it's a very important part. Okay, and so we first discuss the interface and how the collections interface hierarchy, how that works. Okay, and in Java collections, it has two top-level interface. One is collection, the other is map. Okay. And for collection, it's used for single object. So it's about an object. Okay. And for map, it's not just about the object, it's about key value pair. So this is new. Okay. So it has key and value pair, not just a collection. No, collection is like a collection of animals, that a collection of books, and the map concept is, yeah, you have a group of animals, but they also each animal also have something to keep track of it. We call it a key. And the animal is a value, okay, the group of that. So using with the key, then it's easy to find the respective value. Okay, so that's the concept. So in Java, we call it a map. And in the hierarchy, so from collection, there are three sub-interfaces: a list interface, queue interface, and a set interface. Okay, and for map, then it has sorted map, and we will move to the next slide to take a more detailed discussion about this interface hierarchy. Okay, so we just said for the collections interface, it has two groups. Okay, collection for single group of object, map is for a group of key value pair. Okay, and under collection, we have three sub-interface: list, queue, and set. So what's the difference among that? Is it so for list? So if you wanted to have ordered collection, and also the items in this collection also allow duplicates, then you can go with the list interface. Okay. For queue, yeah, it has a special feature as first in, first out. We call it a FIFO behavior. Okay. So it has first in, first out also. It's not like a list can be accessed anywhere. It's just the two ends, okay, front and back. And from queue, then we have another sub-interface. We call it DAC. So DAC, it's not just you can add at back. So first in is add at back. Okay, for queue. And out it's remove at front. But for that is you can add and remove at both ends. Okay, so DAC basically the name comes from double-ended queue. Okay, it's double-ended queue. You can add and remove at both ends. So that's DAC. And set is collection, but it doesn't have order. Also, the major features doesn't allow duplicates. So it only allows unique items to be stored. Okay. And from set, it has sub-interface, sorted set. Sorted set based on the name we can guess is it allow ordering. Okay. So not like a set itself. Set itself doesn't have ordering requirement. And then from sorted set, we have sub-interface of navigable set. Navigable set also allow navigation operations. Okay. And similar for map, it also has sorted one and the navigable one, okay, the sub-interface. And their features are similar as sorted set and navigable set is one sponsor sorting and the other also, in addition of all the above features, it also supports navigation. Okay, and then let's take a look each of the interface. Okay, so at the very top, we said there are two interface, collection and map. Is that so? let's first discuss collection. So this is about generic. Okay, so that's some reference type. So collection, the common feature for the collections is support adding, removing, search, and traverse. Okay. And in the collection, we can see it has a number of methods like add. You can add a single item. You can also add another collection. Okay. And we can do remove single object. You can also remove a specified collection. Okay. And you can also specify some condition for removing, okay? And this method is a default method. Okay, so that's for adding and removing, and you can also do search like a contain, is it to search for a single one or search for a collection. And it also supports traversing. If we take a look, it does have the iterator. Okay, so iterator support uh, the iteration, so traversing. Okay, and it also has some other methods. We were seeing an example like a string. Okay, so then it will return a string representation of the collection, and it's quite useful for this. Okay, it also supports to do the convert to return an array containing all of the elements in the array. Okay. Yeah, we can see it's uh, quite useful. And then the collection has three subinterface: list, queue, and set. Okay. And if you recall for list, it's ordered. Okay. And also it allows duplicates. Okay. So definitely it has the add, remove, search, and traverse. So those operations from collection. So it has, so beside that, it also allows one of the features is indexing. Okay. So that's quite useful for faster accessing. Access. Okay. And for traversal, it's not just forward at all. Also support backward traversing. Okay, using list iterator. And because of the indexing, so it also allows traversing start from a specified index. So indexing and traversing start from a specified indexing, not supported in collection. Okay, it also allows sorting. Okay, so that's some adds-on features. So you can see it as add, and with add it also has the add index. Is that yeah, specify at a specific index. And for the access of index, so you can specify the index and get the item to also give you where the object is. Is it? So this two is traversing forward and traversing backward. Okay. For the not this one, it's list iterator. Okay, that has remove operations, and it also give you a set. So update the element at the specified index. So this set operation. So list interface also allow you to update some specific element, but you need to specify where it is. Okay, and the sort operation, sorting. Okay, and like the two array. So this is a list operation, list interface, and of the operations that it supported. Okay, the second subinterface, that's from collection interface is queue. And queue, remember, is a first in, first out, okay, feature. So add at end and remove at back, okay. So it has, so for add operation, it has two sets, add and offer. For remove, it has remove and pull, okay. And you can also retrieve. So this is retrieving, retrieve from item. So each it has two sets, and the difference between these two sets is for the add, remove, and the element for these three operations. So if fail, then it will throw exception. Okay. So it will throw exception. Throw some exception. So that, and for the other three one, it will just return true or false. Just return true or false. Okay. So that's the difference. So when you select which one you want to use, depends on if you want to throw exception or not. Okay, and so we have Q as that, and under Q, then we have the DAC interface. So DAC is double-ended Q. Double-ended Q. So it allows add and remove at both ends. Okay. So yeah, it has the add operation. You can see add. It also has add front as it, and for remove, it also allows to remove first. Okay. So it also has uh, the respective uh, like a pull, push, pop, those operations. Okay. So the difference, like just Q explained, two group, one group through exceptions, and the other just return fields. Okay. And it has like a get first, get last. Okay. And offer first, offer last, pick first, pick last. Okay. So the respective operations. So you can take a more close look and see the specification about each operation, and then decide which operation you should use when you have the application. Okay, the third interface is set interface. So set allows add, remove, search for individual that, as well as traversing. Okay, and remember set doesn't allow duplicates, unique items. Okay, so the item must be unique in this collection. Uh, but it's not ordered. Okay. Not ordered, not like a list, okay? So its add operation does not specify where an element can be inserted. So that's different, okay, from the operation that we saw before. So it has like those add, and this is to do search, and you can do remove, okay, and to array, same thing. Also allow traversing. So that's that. Then it's sub-interface, direct sub-interface sorted set. Sorted is based on the name. We know that it's allow ordering that. So the basic is it's allow ascending order. Okay, and this is based on either natural ordering, so using comparable interface, or comparator specified. Okay, so customize all the comparator interface. So depends. Okay, so it also allows retrieve. So in addition of the set operations, it also allows us to retrieve the first and the last. Normally, that's only allowed in a DAC, but set also allows with the set sorted set. That's because it's already sorted, so it makes sense. You can retrieve first and the last, minimum or maximum, as well as some subset. So it also allows subset specified within certain range. That's all because of the ordering. Okay. So yeah, so you see it has the comparator method in the first, and it also has the head set. Is it a head set and return the view of the set with all elements lower to the specified, so the left section is it. And the tail set is the higher or equal, the right part. Okay, it also allows subset, so you can specify the range. And from sorted set, the framework also provide another interface allow navigation. It's called navigable. Okay. So for navigable, it also supports search and report some closest matches to a specified element. Yeah, so this is also quite useful. And also removal of the lowest highest element. And also traversing not in ascending but a descending order. Okay. Yeah, so those are the uh, operations that in addition to sorted set, if you take a look like a ceiling, is it, and the floor, okay, head set, and I remember the tail set operation, okay, and the subset operations. Yeah, and we have an example that illustrate how all of this works. And so there are two top-level interface in Java collections. Okay, so the collection we just discussed all of the previous discussion about collection interface and its subinterface. So if you take a look, if you recall, we also discussed another set. It's map. It's for key value pair. Key value pair. Okay. And so for the requirement of key value pairs, the key must be unique. So that's one requirement and also immutable. Okay, we don't like mutable object can serve as key. Okay, and it support, so for map, it also support add, remove, search, retrieving and updating elements. Okay. Yeah, so there are a lot of similarities also regarding operations, okay, but the major difference is map, it's key value, and normally key serves as when you do search, if you search by key, it's very fast. Okay, so the advantage of a map is quick lookup. So far, what we learned, the fastest search is binary search. And for binary search, it has a requirement that it must be sorted. If you recall, is that even that's the case, the search is log 2n, is that the time efficiency. But for map, when the search is constant. Okay. Why it is? Because of the key. Okay. Okay, so that's a general idea about map. Okay, so and we will see the map application in our example so that we can have a better understanding about it. Okay, and from map, then uh, we have the sorted map. So sorted is all based on the name. Then it's organized the key ascending order. Okay, so same thing support both nature ordering and the comparator ordering. Okay. And so the listed operations, including like a comparator and a key head map, a key set, and the submap, a tail map, and the values. Okay, so we will see in our examples. Okay, then from sorted, we have the navigable. Okay, so the navigable, so in addition of all of the operations from sorted map, it also supports search and report the closest matching to a specified key, and also removal of lowest the highest element, and also traversing in descending order. Okay. So this similar like a set, but this is for map. Okay, so here's the end of this section. So let's take a look the other national park. Yeah, so here's another national park. And that's I remember it's the highest point of the national park. Yeah, just think about what the national park it is. Okay, so we finish this section and we will come back in a little while. See you.